So in this video I want to talk about complex numbers, which is defined to be um, the sum of real numbers and imaginary numbers. Okay, so the imaginary number is represented by IB, where I is equal to the square root of -1. In the NCEES reference book, I is notated as J. So in the NCEE, that's notated as J. And the reason for this is because it's to avoid confusion with the notation for current, which is also lowercase I. It's also a convention used by electrical engineers. So from now on, we'll refer to it as the lowercase j. So in rectangular form, it'll be A plus JB, where A is the real part and the JB is the imaginary. And we can even plot it on a coordinate axis where x would normally be, this would be the real axis, and where y would be, this would be the imaginary axis. So let's say, for example, we're given the point, or we're given the rectangular form 10 plus 2j. So then that means we're just going to go 10 units on the real axis and 2 units on the imaginary. So this is 2. So this point we'll call 10 plus 2j. You can multiply, add, subtract, and divide with complex numbers. So let's do an example here. Example 1. So we're going to add 5 plus 6j plus 7 plus 3j. And really all we have to do is add up the real numbers separately and add up the imaginary numbers separately. So this will come out to be 5 plus 7 plus 6j plus 3j. And when we simplify it, we're just going to get 12 plus 9j. So similarly, we can subtract. So this will be example 2. So if we're given 5 plus 6j minus 7 plus 3j, again, we're subtracting the real numbers and the imaginary numbers separately. So it would be 5, and I'm distributing this negative to both terms. So 5 minus 7 plus 6j minus 3j. And if if we simplify this, this will be negative 2 plus 3j. So our next example will be dividing with complex numbers. So example 3, we're going to divide 3 plus, say, 5.2j divided by 4 minus 7j. So in order to divide with complex numbers, you have to multiply the denominator and numerator by the denominator's conjugate. So as you might recall, if we're given a plus b, the conjugate would be a minus b. So the denominator's conjugate will be 4 plus 7j. And if we multiply the denominator by 4 plus 7j, we have to multiply the numerator by 4 plus 7j. So essentially we're multiplying by a ratio of 1 to 1. So this will equal 12 plus 20.8j plus 21j plus 36.4j squared divided by 16 minus 49j squared. So if we want to simplify, the j squared is basically j squared off to the side. J squared is basically square root of negative 1 squared. So that this square will take away the square root, so we're going to be left with negative 1. So wherever there is a j squared, we're going to replace it by negative 1. So we can simplify this to be 12 plus 41.8j minus 36.4, because this j squared turned into a minus 1. In the denominator, this will also make this negative sign here be a positive. So if we take care of that, if we add 16 plus 49, we get 65. So again, if we simplify this further, we should get negative 24.4 plus 41.8j divided by 65. So we can divide the 65 to both terms, and finally it should be negative, or about approximately negative 0.375 plus 0.643j. And that's it for complex numbers.